Today we are going to talk about DS18B20 sensor with STM32 NUCLEO using STM32 CUBEIDE. So in this session we will learn how to interface DS18B20 temperature sensor with STM32 NUCLEO and program it in STM32 CUBEIDE using HAL libraries. So firstly, I will briefly introduce you to DS18B20 sensor, then interface it with STM32 and program it for temperature measurement using this STM32 CUBEIDE. Okay, so for demonstration we will connect to SSD1306 OLED with the STM32 NUCLEO to display the sensor data on the OLED. Okay, so DS18B20 is a temperature sensor that is single wire programmable in nature. So it is widely used to measure the temperature of chemical solutions and substances which are present in a hard environment. Okay, so one of the advantage of using this sensor is that we only require a single pin of our microcontroller to transfer the data. So thus, it is extremely convenient to use this sensor with the microcontroller as we can measure multiple temperature by using the least number of pins of our development board. So this table shows some key characteristics of a DS18B20 sensor. The operating voltage is about like 3 to 5 volt. The temperature range is about like minus 55 degrees Celsius to 125 degrees Celsius. Accuracy plus or minus 0.5 degrees Celsius, and the output resolution will be like 9 to 12 bit. And coming to the pinout, a waterproof version of this sensor is also available in the market. This is actually how it looks like. This figure shows the pinout of the DS18B20 sensor, and this diagram shows the pinout of the normal DS18B20 temperature sensor. It is actually look like LM35 sensor, right? Coming to the pin configuration details, this temperature sensor also comes in a single package module which contains a sensor and a pull-up resistor. If you are using a module, you don't need to connect any external 4.7K ohm resistor. This is because the module already has an onboard pull-up resistor. So here I provide the connection detail. You can connect it accordingly. So connect the DS18B20 sensor and OLED with the STM32 NUCLEO as shown in the diagram over here, and here I provide the diagram also. No, I didn't mention it in the slide. I will send you to in the downloadable part. Okay, so you can go and grab it in the downloadable part. Here I just provide the table. So DS18B20 ground to ground, data pin, whatever the pin that you have taken, VCC to 5 volt, and you already know how to connect OLED display, right? So the connection picture I will provide you in the downloadables. Okay, so these are the library that we needed for this program. I will also provide all those library in the downloadable part. And now we can go for IDE. Let's do project setup. Okay, over here as usual go to system code or CC, enable this HSE and then go to timer 1 and set the clock source as internal clock and go for the parameter settings over here set the pre-scalar as 63, okay, and set the, scroll down, trigger event selection as reset. Make sure that it will be in reset mode, and then come to connectivity I2C1, this is for OLED I2C, and set the standard mode to fast mode, and then over here select PA1 pin as GPIO output pin. Where is PA1? Here it is, PA1 GPIO output pin, and then go to clock configuration, set this to 8, change this to HSC, PLL clock, and over here 48, okay, hit me enter, save this, yes, yes. Okay, so now one more thing is we need to provide all the library over here. So to acquire DS18B20 temperature readings with STM32 NUCLEO using STM32 CUBEIDE, we will require DS18B20 and one wire libraries. Okay, so let me show you how to include them in your project in order to access the APIs which is provided by each of them. Okay, so for that go to core and go to INC. Okay, just a minute. I will provide you all the library in the downloadable section. Okay, so here create new file and name it as ds18b20.h. Okay, it will open. Just a minute. I'm already having this with me. Let me copy it and let me paste it over here. Okay, so DS18B20, and then again in core INC create one more file called onewire.h. Okay, INC new file, here onewire.h, finish. Paste this. I will provide all the libraries in your this is not F1, this is F4 we are using. Okay, and okay, you can cancel this, and now go to source file. Okay, so here also we need to create two more file. Go to source, new file, ds18b20.c. okay, over here. Okay, this one, and another file which is called onewire.c. Finish. Okay. Save this. We have successfully created all these files. Okay, so now for OLED we have already provided you all the OLED libraries, right? So just paste all those 4 libraries over here, fonts.c, fonts.h, and ssd1306, ssd1306.c file and .h file. These are all the necessary libraries for us, and then we can go for the main program over here. Okay, so after this we need to include all the libraries. So include onewire.h library, include ds18b20.h library, and then include string.h library, and then include standard input output .h library, and then include fonts .h library, and then include SSD1306.h library. So these are all the necessary libraries. Now scroll down, and after this, inside this user code begin, here I am going to give float type, temperature variable, and then character array string. Let me give like 64 is pretty much enough, okay? And then go for int main, and after all these initialization, in between the user code begin to SSD1306 initialization, okay? Now DS18B20 initialization. Inside I am going to pass DS18B20 resolution, which is 12 bits. Okay, so initializing the DS18B20 sensor with 12 bits resolution by calling DS18B20 initialization and specifying the sensor resolution as a parameter inside this function. Now we can go for while loop. So inside DS18B20 read all, DS18B20 start all, okay, and then unsigned integer 8 underscore t ROM TMP. Inside I am going to pass just 8, and then unsigned integer 8 underscore t variable I. And now I am going for a for loop. I which is equal to 0, I which is less than DS18B20 underscore quantity, and I plus plus. Inside this for loop there is another condition, which is if condition. If DS18B20 get temperature, instead I am going to pass I comma address of temperature. So inside this I am going to write few lines. So DS18B20 get ROM, instead I am going to pass I, and then TMP. So inside this condition, just a minute, the next line, mem set, instead I am going to pass string comma 0 comma size of, I am going to pass the string, okay, and after that I am going to use sprintf string, instead I am going to give like percentage .2f Celsius, and then the temperature. Okay, now SSD06 underscore set cursor, inside I am going to pass. So here you need to enable the printf. You already know that, right? So don't forget to enable the printf. Instead I am going to pass the position 20, 0. Okay, SSD1306 underscore write string. So inside I am going to pass temperature address of fonts, not fonts, font size 7 into 10. We will all find all these stuffs in the library itself, okay? And then SSD1306 underscore set cursor 25, 13. Now again SSD1306 underscore write string. Instead I'm going to pass the string font underscore 11 cross 18. Okay, so I should 11 cross 10, and here I am going to set this to 1, and then SSD1306 update the screen. Okay, so after all this I am going to end it with the delay. Just 1 second is enough. So this is all about the programming part. Go to DS18 properties, C++ build settings, MCU MPU settings, enable this 2 things, apply and close. So this is all about this programming part. You already know the connection over here, right? So I will provide the connection picture in the downloadable. So here I provide the tabular column also. Connect this accordingly using this column, right? So write the program and you will get the output accordingly.